Okay, today we are going to learn how to derive or how to prove Euler's formula. What is Euler's formula? E power I theta is equal to cos theta plus I sin theta. This is this is called Euler's formula. So how to derive this Euler's formula? Let us learn about Euler's formula and how to derive Euler's formula today. We know that whenever a function f of theta has its derivatives, all derivatives in between 2 points or in the interval a to b, when the first derivative of the function becomes 0, then that function should have a constant value between that interval or in the interval. Okay, let us take f of theta is equal to, okay, cos theta minus I sin theta e power I theta. This is the one function. Okay, when f prime theta is equal to 0 in any interval, let us say it would be for all values of theta in between or in the interval a to b, then f of theta must be a constant for all values of theta in the interval a or open interval ab. Let us see this one also open interval. Okay, so how to prove this? Even by using mean value theorem also we can find this rule. Like what is mean value theorem? Let us say f prime c is equal to f of theta 2 minus f of theta 1 divided by theta 2 minus theta 1 is equal to 0. When f prime theta is equal to 0, then f of theta 2 minus f of theta 1, this implies f of theta 2 is equal to f of theta 1, where theta 2 is not equal to theta 1 for all values of theta in between theta 2 theta 1. So this is called mean value theorem. Okay, let us derive Euler's formula. Let us take this f of theta is equal to cos theta minus I sin theta e power I theta. Let us differentiate this function. F prime theta is equal to cos theta minus I sin theta. This is in u form. This is in the form of uv. Let us consider this as u. This is v. So u times v prime. V prime means e power I theta times I plus v times du e power I theta times minus sin theta minus I sin comes cos theta. So just use product rule of differentiation, so we will get this one. So we can take common e power I theta outside, e power I theta then I cos theta minus I square sin theta minus sin theta minus I cos theta. So this becomes e power I theta I cos theta minus I square, means I square is equal to minus 1 because I is an imaginary number. So this becomes plus sin theta minus sin theta minus I cos theta. So I cos theta and minus I cos theta, sin theta minus sin theta is cancels out and this becomes 0. So finally this becomes 0. So f prime theta is equal to 0. So this gives rise to f of theta must be constant for all values of theta in an interval theta 1 to theta 2. Okay, so what is f of theta? F of theta is equal to cos theta minus I sin theta e power I theta. This is the actual function we are considering. So this must be equal to some constant at all for all values of theta. For example, let us take theta is equal to 0 in radians. 0 radians, let us say. So then f of theta is equal to cos 0 minus I sin 0 times e power I 0. So this becomes cos 0 radians is 1 minus I sin 0 becomes 0 and e power I0 becomes e power 0, that is equal to 1 minus 0 times 1, that is equal to 1. So our given function reduced to cos theta minus I sin theta e power I theta became 1 for all values of theta. So let us multiply with the cos theta plus I sin theta on both sides. Multiply with cos theta plus I sin theta on both sides. On both sides of the equation. Then cos square theta minus I square sin square theta times e power I theta is equal to cos theta plus I sin theta. That implies cos square theta minus and I square becomes minus, so this becomes cos square theta plus sin square theta, that becomes 1. So e power I theta is equal to cos theta plus I sin theta. So this is the Euler's formula. E power I theta is equal to cos theta plus I sin theta. So Euler's formula. This gives the relation between trigonometric functions and hyperbolic functions. This is very important formula in mathematics, derived by Euler, Swiss mathematician. Swiss mathematician. So thanks for watching.